show you the motor nerve conduction study of the ulnar nerve to the abductor digiti minimi. We put the recording electrode over the muscle belly of the abductor digiti minimi. The reference is put as far as possible on the fifth finger. We put, as used before, the ground electrode in between the stimulator and the recording electrode. The stimulator will be put with the cathode pointing towards the recording electrode at a fixed distance of 7 centimeters. We put a marker at 7 centimeters. On the screen, we have a sensitivity of 5 millivolt per division. With the button zoom, I can change the sensitivity to 7 or to more. The sweep duration is 50 milliseconds. I like to work with an electrical stimulator because in one hand you can change easily the poles, the stimulation, and to go to a proximal stimulation site. The felts are a little bit wet, and we put the cathode over here, over the ulnar nerve. We stimulate, for example, at 10 milliamperes. We give one stimulus, and we wait for any response by increasing stimulus intensity. Over here, we see a beginning compound muscle action potential, which is of course not a full amplitude. We change the position of the stimulator a little bit more to the lateral side. The answer is less, so we go to original position, and over here we stimulate a little bit harder. At 20 milliamperes, we get a very nice compound muscle action potential. The triggers are put immediately by the computer on the right place, on the beginning, on the top and on the end of the negative deflection. We go to supramaximal answer by increasing the stimulus intensity. As you can see, I have to switch the sensitivity a little bit because the answer goes out of the screen. At 38 milliamperes, the amplitude of the compound muscle action potential remains the same. We have a supramaximal compound muscle action potential. By pressing the button next, the system is ready for a more proximal stimulation. We put a marker under the elbow, taking into account that the distance between the under and above elbow position should be at least 8 to 11 centimeters. Over here, on this place, the ulnar nerve lies deeper under the muscle bellies of the flexor carpi ulnaris. That's why the stimulation intensity should be a little bit higher to get the same waveform and to get the same amplitude of our compound muscle action potential. Stimulating at 38 milliamperes over this place, we get a very small answer of the compound muscle action potential. I will move a little bit the stimulator to see whether the compound muscle action potential changes in waveform. Over here, a little bit more to the medial side of my original position, I get a very nice compound muscle action potential. This one is not supramaximal yet. I told you the reasons why we have to stimulate a little bit harder on this under elbow stimulation. We get an amplitude so far of 7.5 millivolt, still a little bit lower than the distal supramaximal compound muscle action potential. I stimulate a little bit harder and I see that the amplitude is increasing till 8.2 millivolt. It's acceptable. You see it as well on the superimposed recordings. By clicking on next, I will move towards the above elbow stimulation. Again, I want to be the distance between the under and above elbow stimulation as big as possible. I take, for example, 10 centimeters. I put a marker here, and I'm going to stimulate at this very proximal stimulation. The cathode pointing towards the recording electrode, and I give one stimulus. I lower a little bit the intensity because now the ulnar nerve is more superficial and is very close to my stimulator. I hold the arm, I give a stimulus, and immediately I get a supramaximal response. To check, I will increase by, for example, 10% and start again a stimulation, but the amplitude remains the same. So this is a good recording of a ulnar nerve to the abductor digiti minimi. We check for the velocities by measuring the right distances in between the different stimulation sites. Between wrist and under elbow, we measure 215 millimeters. We write over here this distance, 215 millimeters. We get a conduction velocity of 50 meters a second. Between under and above the elbow, we measure a distance of around 100 millimeters. The conduction velocity is 48. As you know, to explore for an entrapment of the ulnar nerve across the elbow, there should be at least 10 to 20% decrease of the conduction velocity in between under and above elbow. Over here, the distance wrist ADM was 70 millimeters. Let's move on. After having this completely normal recording of a distal latency, velocity and amplitude of the ulnar nerve, let's move on to the late response. We put the electrodes on the same places as for the motor nerve conduction study, and we will stimulate over here on our distal stimulation side. To move from the motor nerve conduction study to the F wave, we can press the F wave button over here. We choose the nerve conduction velocity segment to be imported from the motor nerve conduction study. We will use the distal stimulation side. Immediately, we see the compound muscle action potential and the late response that was recorded at a supramaximal stimulation of 38 milliamperes. For the F wave, we will do a repetitive stimulation now from number 2 till number 10. Over here, you see a superimposition of the different recordings. To get a good recording of the late response, we ask the patient to distract attention from the examination. So please, Miroslav, try to open and close your hand during the whole examination, as well as clenching the teeth very firmly during the whole examination. Okay, and now we can start our stimulation. I go to next. When I press on stim, there will be repetitive stimulation of supramaximal 38 milliamperes. The 10 stimulations are superimposed over here. The computer immediately measures the minimum F-wave latency. I move this bar as well to the beginning of the minimum F-wave latency. As you can see, we record 27.8 milliseconds, which is a normal F-wave latency. So the superimposition function is happening immediately on this machine, automatically, and this is quite useful.